For this question that is on PnC in the November 2004 paper, okay, so there is 10 canisters. There are 10 canisters, okay, to be arranged in this room in the diagram below, okay. In how many ways can the canister be placed on the bases? So for the first part, it is quite straightforward. The number of ways would be, now you want to arrange 10 canister, that would just be 10 factorial, and you will get your answer, because that is the way to arrange 10 canisters, okay. So for part 1, all right, now I want to do some restriction. How many ways can there be such that there are two particular canisters that must not be placed on A, E, F, and J? Okay, so this, let's say we call these two particular canisters C1 and C2. Now, if I take C1 and C2 out of the equation, the number of ways that is going to be left to the number of canisters that I can have left is 8. There are 8 left for me to choose, or rather permute, because in this way there are A, B, C, D, E. Each of the base is distinct. Okay, so I have to permute. Permute how many? Permute 4, because these are the four places that I can put for these 8 other canisters. And so even if I choose 4 already, these 4, let's say C3, 4, 5, 6, to be put in A, E, F, and J, I can rearrange them, and those are going to be different ways. So that's why I have to use 8 permute 4. Multiply by, now after I have settled these 4 already, let's look at these 6. There are 6 slots to put the rest of them, which includes C1 and C2. Okay, so 4 of them already are in the blue slots. How many canisters I have left? I have 6 canisters left to put in these 6 ways, and then I have to rearrange them as well. So the number of ways would be 6 factorial. And if you multiply it on your calculator, you should be able to get your answer. Okay, so for part 2, if 2 particular canisters, no, let me erase this first. Okay, if 2 particular canisters cannot be placed, must not be placed, so we use the complement method. That means what happens if I assume that, again, let me use C1 and C2. Let's say C1 and C2 can be placed together over here. Okay, so now C1 and C2 are in a group. How many options are there to move C1 and C2 around? Okay, so there's 1. Now if I move to here, 2. Move to here, 3. Move to here, 4. Okay, and that will be the same as the other side. So there will be 8 ways of moving C1 and C2, because the C1 and C2 can also be here, 1, 2, 3, and 4. So there are a total of 4 ways to move C1 and C2 together if they are placed side by side. C1 and C2 can also switch place. So if I put C2 first and C1 on second, that would be a totally different way. So I multiply it by 2, because C1 and C2 can change place. By right, it's going to be called 2 factorial. Okay, that is for C1 and C2 to switch place. Now, let me erase this. If C1 and C2 are here, how many ways can I arrange the rest of them in the other 8 slots? That will be multiplied by 8 factorial. Okay, but this is your answer if C1 and C2 are together. Okay, so if I want to find in such a way that, because the question says they must not be placed together, then in order to find the number of ways for my answer, I would use the total number of ways. What would be the total number of ways? You have already found in part A over here. 10 factorial, yeah, minus away the previous answer, which is 8 times 2 factorial times 8 factorial, and you should be able to get the answer if C1 and C2 are not to be placed beside each other on the same side of the shed.